Hello Aiden, this is the circuit I came up with for your request of a stop and a start float to control a sewage pump. I did add a couple things in there so that we can control it, and two indicating lights to see when the pump is on and when it's off. So I can interpret this. So we have power coming in to your stop, your start, and over to a relay. Hit start. This is going to latch in and your relay will maintain energized. In parallel to that, there will be a green light. Green light will turn on when the start button is pressed down. Instantaneously, this set of contacts from this relay that just energized will then provide a path for electricity to go to the first float switch, or the one you named it the stop float. So when it gets to the stop float, it does nothing. The water level is then going to rise. Once the water level rises high enough, it's going to close this first float switch, and then it's going to parallel out to a set of contacts from the motor starter coil and also to the second or the start float switch. Water level keeps rising, and then until it hits the second start float switch, and then it closes. It's going to energize the motor starter coil. This is going to energize, and the motor is going to turn on. When the motor turns on, there's a set of auxiliary contacts that is also going to close because the motor is on. This set of contacts will keep the motor starter coil energized. As long as that is energized, we have a path for the motor starter to stay energized, which will keep the pump running. Because once the water level drops back down, this switch, this float switch, is going to open back up, which we won't have a path to go back to the motor starter coil. So then it's going to take this path. It's going to keep the pump running until it drops below that first float switch or that stop float switch. So when it drops below, this opens back up, and then it cuts all continuity to the motor starter coil. The sewage pump then stops pumping. If we would stop the whole circuit, if we would hit stop, the relay de-energizes, and then this is a normally closed set of contact. Power would come right to this red light. The red light would flash on, indicating that we have no control power to our sewage pump system. And as long as we have control power to the relay, this contact here will provide power to the float stop. As long as the relay is energized, the sequence will repeat itself once the float switches are both closed. Water drops back down, both float opens up, cuts power to the sewage pump, wait for the water level to rise again, closes the first switch, and then it closes that second high level switch or the start float. Motor starter coil for the sewage pump energizes again, locks itself in. It will keep draining until this float and this float both opens up for it to stop again.